Hello everyone, this is Akansh Suman here, and now we are going to solve the questions based on the Proell Governor. So what is given in the question? First we have to read the question carefully, then we will solve it. Okay, and the diagram we will draw according to the question. A governor of a Proell type has each arm 250 mm long. That is the first thing that is to be noted, that the length of the each arm is 250 mm. Okay, and we have to draw the diagram. The pivots of the upper and the lower arms are 25 mm from the axis. That means it is having an offset. So we can draw the diagram now. This is the governor axis. This is the axis of the governor, you can say the axis of rotation. Okay, and this is a sleeve where lower arm is going to be attached, and it is having the offset. This is offset, and the length of offset is 25 what is 25 mm. So that is 25 mm. Okay, that is 25 mm. Now see here, this is the pivot point, but we are measuring the height of the governor from the point of intersection, so we can extend it up to the axis of the governor, and the height of the governor would be measured from this. Okay, this is the radius of governor, and this is the height of the governor denoted as h, and this is r. Okay, now in the question it is given that this is 250 mm long. Okay, now central load on the sleeve has a mass of 25 kilograms, so capital M value is 25 kilogram, that is 25 kilogram, and each rotating ball has a mass of 3.2 kilogram, so that is 3.2 kilogram. When the governor sleeve is in mid position, the extension of the lower arm is vertical. What it is saying, that now we have to draw the extension of the lower link, that is in a vertical position. When the sleeve is at its mid position, it is in vertical position, extension of the lower link. Okay, this is in a vertical position, and it is having the fly balls. Okay, this is the fly ball of mass 3.2 kilogram, and it is saying that the radius of path of rotation of the mass is 175 mm. This is completely, radius of rotation is 175. This is completely 175 mm. Now we need to first calculate the length of the extension link, while the governor speed is 160 rpm when in mid position of the sleeve. Okay, the governor speed is given, that is n is given, that is 160 rpm. 160 rpm speed of the governor is given, and we have to calculate the extension of the lower link length. This is 160 rpm, and another thing which is given, that the vertical height of the governor is 200 mm. Vertical height h value is given, that is 200 mm. 200 mm is given. Now we have to calculate the extension of the extension link length we have to find out. Now we all know that we have to use the governor speed formula. Okay, but you have to understand this is a Proell governor, and we all know that Proell governor radius of rotation r dash is greater than equal to r. That means the minimum radius of rotation would be equal to r when the extension of lower link is in vertical position. So it is talking about that r dash is equal to r, and we have derived the direct formula. When there is a r dash is equal to r, we have derived the direct formula that n square is equal to 895 upon h multiply a upon e multiply 1 plus mg 1 plus k upon twice of mg. Okay, twice of mg. Now see here, this is a length a, e and h, all are in meter. Don't put the values in millimeter. You just have to understand this, all the data in this formula we have to put it in meter. Okay, So now we have to calculate the A and E because H is already given in the question. We have to calculate the value of E. So for finding out the value of E, we have to complete the Proell Governor diagram. So this is the instantaneous center, okay, and this is the length A. This is A, this is C, and this is B, and we all know this is distance is 25 mm because it is the offset 25 mm. So 175 minus 25 because this is complete length, okay. So 175 minus 25 is 150. That means it B would be, the value of B would be, that is 175 minus 25, that is equal to 150, okay. So that is 150 mm, the length of B. Now see here, we all know that the all arms of the governor is of 250 mm length, okay. So if this is 250 and B value we have calculated as 150, that means it is 150, that is 150. So we can easily calculate the value of A. So A value that we will get 250 square minus 150 square, and finally when you solve this you will get the value 200 mm. 200 mm. Now we have to calculate the speed, sorry, we have to calculate the length of extension link, and we know that length of extension link, how can we calculate? We know that A is equal to E is equal to A plus, for example, assume that the length of extension link is X, okay. So A plus X would be the value of E because we know that E is calculated from the fly ball to the instantaneous center. This is E, or E is equal to A plus X, okay. We all know the value of A. We have calculated the value of A, that is 200 mm. So that would be equal to 200 plus X. Now we need to calculate the value of X. This is the first part of the question, okay. So we put all the data in this equation number 1, okay. So n square is, n value is 160, so that is 160 square, that is equal to 895 upon H. H is 0.2, and what is A? 0.2. I am just putting the value in meter, and that is you can either write E or you can write it as 200 plus X, that means 0.2 plus X. We will put the value E here, that means we will put here E, then we will convert into X, okay. Then we can calculate the value of X finally, but I'm directly here putting the E here directly, okay. So that is 1 plus capital M is what? 25 G, 1 plus K. Now what is the value of K? K value is 1 upon 2 mg. M is what? 3.2 G. G to G will cancel out. Now how I write K is equal to 1? Because K is equal to 10 beta upon 10 theta, okay. See here, this is the pivot point of lower and the upper arms. So the pivot point are having the offset 25 mm, that means both are having 25 mm offset, okay. So if this is 25 mm offset, so that means this is length 250 and this is also length 250, and both are on the same pivot point, that means on the same line of action. You can say here this is the line, so that means the angle would be same, that means theta is equal to beta, okay. If one is at the 25 mm offset and one is pivoted on the governor axis, then there will be a difference between the angles, but here both are pivoted on the same offset, that means same particular distance from the governor axis, then it is having the same angles because the length of the arms are having the same value, okay. So that's why theta will be equal to beta. So if theta is equal to beta, if theta is equal to beta, that means 10 beta upon 10 theta would comes out to be 1, okay. So this is beta, okay. Now We just have to calculate the value, and from here you can calculate the value of E. So the E value that you will get, that is 0.30308. This would be the value in meter, and we all know that E is equal to A plus X. That means if I write E in mm, so it would be 308 is equal to 200 plus X. Okay, so X, the value of X you will get 0.108 or 108 mm, or X value you will get in meter, that is 0.1 meter. This is the length of extension of lower link. Okay, this is the length of extension of lower link. So the answer is, the first part answer is 0.108. You can write 108. Okay, now the second part, what is given, what is asking, that the tension in the upper arms. Now we have to calculate the tension in the upper arms. So we just have to draw the diagram again, so in order to understand it properly. Here we have seen in the Proell Governor topic that this is the tension T2 and this is the beta, and we know that T2 cos beta is equal to mg by 2, because this is the half portion of the governor. We have calculated this is mg by 2 also. We generally calculate the things by considering the governor half portion. Okay, this is theta, okay, this is T2 and this is T1. Okay, if this is T1, we all know that this is theta and this is vertical, that means it is also theta. So it would be, that is T1 cos theta, and there will be a downward mg force acting. So that is a mg downward force acting. So see here, this is the complete diagram. I am just drawing here. You can see here, this is T2 and this is beta, so this is also beta, this is also beta. So in the question it is asking that find out the tension in the upper arms. That means we have to calculate the tension in the upper arms. That means we have to calculate T1. So we just need to write the equations. T1 cos theta, we have to balance vertical forces, we have to make equilibrium of the vertical forces, that is T1 cos theta in the upward direction. Okay, T1 cos theta in the upward direction, and there will be a mg force in the downward direction of the fly ball, and there is also, this is T2, and so that would be T2. Okay, if this is T2, this is T2, this is T2, that means this would be T2 cos beta, So I can write here T1 cos theta is equal to T2 cos of beta plus mg. And what is T2 cos beta? This is the mass of the fly ball. Okay, and T2 cos beta, this is our first equation, and we know that T2 cos of beta is equal to mg by 2. Okay, this is equal to mg by 2. So you directly put the value of T2 cos beta in this equation, and you will get the value of T1 cos of theta is equal to mg by 2 plus mg. Okay, now first we have to calculate the value of theta, then the answer will become. Okay, so how can we calculate the value of theta? Since if I consider this triangle, we all know this is 250 mm long, and this is complete 175. This is complete 175. So this length would be 150. So this length would be 150 from here to here. Okay, because the offset is of 25 mm. Okay, now see, in this triangle you can calculate the value of theta. Sin theta is equal to 150 upon 250, and you will get the value of theta, that would comes out to be, theta would be 36.86, and the cos 36.86 is 0.8. So that would be T1 multiply 0.8 is equal to mg. The mass of the sleeve is given in the question already, that is 25. 25 multiply 9.81, this is gravitational acceleration, plus 3.2 multiply 9.81. You just have to solve this and you will get the final answer, the tension in the upper arms. So this would comes out to be 192.5 Newton. Okay, so the answer is 192.5 Newton. This is the tension in the upper arms. You can also calculate by putting the T1 value in this equation and you will get the value of T2. You just have to calculate the beta angle. Similar, we all know that theta is equal to beta, so from here you can calculate the tension T2 also. So I'm just calculating here the tension T2, that means the tension in the lower arms. However, in the question it is asking that find out the tension in the upper arms, so this is the answer. I'm just calculating the T2 also. So T2 cos of beta, we all know that beta is equal to theta, so that is 192.5 cos theta is 36.86, that is cos theta is equal to 0.8, and that would be minus mg. So mg is 3.2 multiply 9.81. So you can calculate the T2. We all know that theta is equal to beta, that means it is also 0.8. Okay, that is 122.6. T2 will be 153.26 Newton. That would be the tension in the lower arms. I hope you will understand how to solve this question properly. Okay, so thank you.